Hi everyone, today we are going to discuss about inverse kinematics in robotics and automation medicine. First of all, what do you mean by inverse kinematics? It is stated as the determination of all possible and feasible set of joint variables which would achieve a specified position and orientation of the manipulator's end effector with respect to the base frame. It is called inverse kinematic. And for this, we have to analyze the workspace of a manipulator, and thus the workspace of a manipulator can be classified as a reachable workspace RWS and dexterous workspace DWS, the region that can be reached by the origin of the end effector frame with at least one orientation is called as a reachable workspace RWS. And the space where the end effector can reach every point from all orientation is called dexterous workspace DWS. And the DWS is either smaller or same as RWS. It depends upon the application that we used. And the next one is solvability of inverse kinematic problem. The inverse kinematic problem is complex because the solution is to be found for nonlinear simultaneous equations it involving transcendental harmonic sine and cosine functions. The number of simultaneous equations is also generally more than number of unknowns. It makes some questions, some equations, it mutually dependent. And the possibility of many solutions, multiple solutions, or non-existence of any solution for given end effector position and orientation, it can be analyzed. And for non-existence of solution, the solution does not exist when the desired point P lies outside the RWS, or even if P is within the RWS, not all orientations are realizable unless P lies within the DWS. If the wrist has less than 3 degrees of freedom to orient the end effector, then certain classes of orientations are not realizable. Because for a manipulator to have all position and orientation solutions, the number of DOFN must at least match the number of constraints. For example, 6. N less than or equal to 6. For this example, in this we have multiple solutions for this existence of multiple solutions, it poses a problem because the robot system must have a capability to choose one solution, probably the best one. The reasons for getting multiple solutions are parallel axis of revolute joints, existence of trigonometric functions in equations, and presence of non-zero joint link parameters, and the range of joint motions allowed. And also we have taken degrees of freedom into account, and for this we have to analyze the parallel axis of revolute joints first, and thus the angles mentioned are theta 1, theta 2, theta 1 dash and theta 2 dash, and we have a point P for inverse kinematic problem conversion. The solutions theta 1, theta 2 is called elbow positions, while the solutions theta 1 dash and